Hello, everyone. This is the headline from today's Wall Street Journal. How many have seen it? How many people here lost money in the Brexit? Guys, either are you amazingly good investors or you have not been looking at a 401 in the last few days. But when I see something like this, it makes me angry because, of course, I lost a lot of money, but if I could afford a financial advisor, I will fire him for something like this. And imagine you are a financial services executive in one of these companies. This is your job today to not only look at the future, but more importantly, de-risk your portfolio based on the information that exists out there. Machines should not be doing your job. Or imagine you are a very senior technical lead in a social media publishing company. Today it's your job to make sure the content on your website is not inappropriate. Or if you are developing an app, it's your job today to make sure you're able to understand, listen, hear, and see what your app's users are using. And this talk today is about making sure you do your job, helping you be successful in your job. This is about how machine learning can help you make sense of the data that surrounds us. I'm Apurv Saxena. I am product manager in the Google machine learning team, cloud machine learning team. And I'm going to talk about how Google is using machine learning to make sense of the data that our own apps generate, but more importantly, how some of the tools that we have developed over the years we are exposing to the developers and the enterprise community today. So unstructured data makes up 90% of all enterprise data. Again, not a very insightful comment, especially in Hadoop Summit. What is insightful and what is staggering to a lot of people is the pace of growth of this unstructured data. Today, we are almost, by Mary Meeker, taking around 2 billion images a day. Your camera, as people say, is becoming the keyboard for your phone. We are generating 20% of all Google search on mobile today is voice search. Again, significant change from just a few years back. And we are generating billions and millions of text information, whether it's blog posts or comments on social media, website, so on and so forth. So all this data is being generated. And traditional BI tools and data tools which are focused on the structured data, not that they are falling short, it's just they are not well equipped to give you insights into this unstructured data that is coming through. So, okay, great. All this unstructured data is coming along, and what do you use it for? As I said, as a media company, you want to make sure that the content that is published on your website is moderated content. You look at whether it's image or it's videos or it's plain text. You want to understand what's in it to infer and control or stop inappropriate content in some cases. You want to understand what's in a photo. Is the person laughing? If they're sad, understand sentiment, whether it's in vision, whether it's in video, image, again in text. And more importantly, and also create structured metadata out of this so that you can now build more sophisticated model on top of it. So this is where machine learning comes. At Google, we have been doing this for the last many years because, to give you an example, Gmail, 1 billion daily 30-day active users generate more than 2 trillion messages a month. And we have been looking at this data and say, how do we make sense out of it? Features such as categorization of your email into promotional updates is based on a better understanding of the unstructured data that is coming in your email. Take example of YouTube. Again, As a publisher, biggest media publisher in the world, you have to understand what's being put on YouTube. Is it copyrighted material? Is it inappropriate material? Something that we have been doing and investing a lot of machine learning talent over the years. And take Translate. Google search, the core product, searches and indexes websites and pages across the globe in multiple languages. You have to understand what is there. So we have done all of this technology over the years, built this technology over the years. We don't believe Google should have all of it. We should expose it to developers. And this is where what I'm going to talk about today. There are two set of models we are exposing, or technology or tools we are exposing. One is a pre-packaged, pre-trained models that you can use out of the box without doing a lot of understanding what's going behind the box or understanding how machine learning models work. You use this as and get started within like minutes. So Google Cloud Translate API has been there for almost 6 years. It's one of the best machine translation service out there, and we are exposing that through Cloud Translate API. We introduced Cloud Vision API early in this year to understand what's behind images, what's inside images. We also launched at I/O, at Google Next, the Google Cloud Speech API, which is really essentially taking audio and giving you text at the end of it. And stay tuned, we are aggressively investing in building this portfolio. So you will see a lot more coming in next few months. But that's not enough, because pre-packaged machine learning models are great in analyzing specific set of use cases, but it doesn't completely address all the problems that we internally face. So other thing we are doing is investing and exposing a lot of our machine learning platform, where you can take your own data, build models, train your models, and then use it in your own environment. And again, the suite of applications we are using, the whole sort of suite of applications is called big data tools. And you can do both the left-hand side on this diagram and the right-hand side of this. By the way, how many of you are playing with TensorFlow or no? So TensorFlow is our deep learning open source framework that we have exposed. This is what we are exposing as part of the cloud machine learning platform is ability to run TensorFlow models on the Google Cloud. So something of this, we got amazing response in the 8 or 9 months we have exposed TensorFlow as an open source platform. TensorFlow right now, I believe, if I'm not incorrect, there are more than around 20,000 GitHub repository on using TensorFlow in some way. And I think that number is increasing almost daily. So that's the sort of set of tools that we offer today. So let's deep dive into two specific APIs that and what developers are doing with it. So the Cloud Vision API, it's really about understanding what's in the image. The number one thing it can do is recognize faces, and more importantly, also recognize what's the emotion of the on the face. It can detect labels and identify labels within an image. OCR is another great example where you can understand if there is a text within the image. It can understand and extract that text. It can understand, identify logos, again, very relevant in a brand media conscious environment. Safe search understands what's in the image or the video and helps you block any inappropriate content relevant to your website. And the third thing is, last thing is, it also helps you understand identifying landmarks. Again, this is built on years and years of research we have done internally in building the knowledge graph. Again, very simple to use API. All you have to do is create a JSON request. In this case, in the case of Vision, embed the image or give a pointer of this image file or set of image files in the GCS, Google Cloud Storage. Call this REST API, and in back you get a response with all the features that we are going to talk about in a minute. Our Google Cloud website has all the details about how you sort of call this API, very simple to use. We have libraries to help you understand, even if you are not on Google Cloud today, you should be able to use this right off the bat. So what are people using this for? And this is where, let's deep dive into a few use cases that will be relevant for here. So image content moderation, again, something that we have built over the years, Google Safe Search, and we are exposing it to this API. It can identify based on the parameter specified what content is inappropriate for a website, and it can essentially block or remove that content from your website. Another is image sentiment analysis. This is the same technology that powers Google Photos. How many of you use Google Photos? And how many of, more importantly, checked out the amazing search feature in Google Photos? This is the cutting edge of artificial intelligence machine learning, where we are able to identify, based on the search, without you ever tagging the image, what is in there in the image. Very, very helpful, especially if you've gone on a vacation and you're trying to know, hey, how can I find that landmark? Give me photos for the Statue of Liberty, and it will automatically search and expose that. The same kind of technology is being powering image sentiment analysis. In this case, it shows not only it recognizes the face, it draws polybox around it, and also tells you the emotion, whether it's sad, sorrow, or happy. Another use case where a lot of media clients are using this API is to use this API to create metadata that they can further use for other purposes. Again, the technology that is powering this is being used today in Google Photos. Another great example of understanding images is understanding text embedded in an image. Think about this, about all scanned documents in the world and your receipts, all ability to understand what's there in the receipts and then use this in other applications, like a expense management application is something easy to do out of the box right now. And this only, even though we have launched this product 6 months back, we have tremendous traction in terms of customers using it. Sony is using it for understanding photos taken from its drones and then creating additional features and insights out of that photos. Wix is using it. Again, they didn't have a big machine learning team inside. They use this API out of the box to better classify the websites and the content they have internal. So no talk is fun without an interesting demo. So let's get into it and let's see if we can get a demo pulled off here. So this is a like pretty nifty thing that we created internally to just test out some of the features that I just talked about. This is something that works today. So we took 100,000 images and run them through Vision API and try to analyze what's in the image. And we created a clustered graph around specific clusters, like, hey, animals and clothing or landmarks and all this. So what you see here is really a structured graph of all, so in this case, jewelry, maps, all these, each node in this clustered graph is an image that we have analyzed. And let's look into some interesting use cases here. So let's take the use case of a dog. Let's see, where is it here? So this is you're looking at the cute little dog here. Can you guys see? Yeah. And here, let me double click on it. So pretty simple stuff to do. It recognizes it's a dog, it's a pet. But is that all we can do? Let's see, if you're doing something on dogs, you could probably do something even better on cats. Let's see. So again, look, not only recognizes cat, which a lot of existing technology can do, it also recognizes that it is a British short hair. And probably, with some probability, it could also be a British semi-long hair. That level of detail and insight can only come through when you have run this API and this through our large knowledge graph. Let's look at, and again, like just to give you, this is, as I said, this is a live demo running in the back end. You send this image out and it sends back all the attributes that you've asked it to identify. Let's take an example of what happens if you run it through an image with text in it. So here, this is a road sign, which is pretty obvious to recognize, but there's some text in it. Can you recognize that text? So here, on the right-hand side, you can see not only recognize it's a road sign, but also identifies what it says. And this is, again, something built on in the back end on the JSON, that response that you get. So if you look here, so this is text annotation. It is identified, it's in English, and it tells you what the text says, is tree, kangaroos crossing. So again, very simple to use. You don't have to understand a lot how that is done, but you can be able to, you should be able to extract very insightful text from your images. Let's take example of, here, let's see. This is a pretty familiar family photo. Surprisingly, not everybody in this photo is happy. Reason to be unknown. But let's see what kind of insights can we get out of this. So number one, it recognizes all the faces, create polyboxes around it. So again, you can do a lot of interesting stuff using this information. But more interestingly, it also identifies who is happy and not happy in this image. So this is really a scale of sort of attributes that we give back. And of course, with the probability of what we believe is most closely resonates the sentiment on the image. And this is something very useful in almost understanding photos from your customers and what are they, understanding sentiments from your customers. Let's take one more example. Here, this is, we can identify, as I said, landmarks. So this is a photo of a stadium, city field. Not only you can run this through your corpus of images that you have, you can actually create insightful and monetizable information out of this. So show me all photos with city feel in the background. And this is something you can get out of the box right now. And again, something very uniquely monetizable and something we were surprised to see such huge demand, which is logo identification in an image. So again, this is used very well in media and advertising space. So not only it recognizes it's a logo, but it recognizes the logo of Android 2.2. So that's the level of detail that's exposed today in this API. Somebody stop speaking me. So let's go back. So that's the Vision API in a nutshell. And let's go back to the presentation. Is this something useful? I'm like seeing no. Do you guys see something like this being useful in your environment today? Yes. Awesome. So this is GA. So you can go right now on the website and start using it. So there's nothing that you don't. This is transaction-based pricing in the sense you pay as much as you use, and something ready to go out of the box. So these are, in summary, the features we just talked about: label detection, OCR, content detection, facial detection. All these are available today, and it's very easy to use API. So same model. Now let's talk about how we are doing on speech. Again, speech comes across as a very common use case across multiple industry and vertical areas that we have identified. So this is as simple as it. You send in audio file, and we send you text in the response. And the beauty of this is can understand multiple languages, the 80 languages and more than that. It can transcribe audio for you. It's more importantly, not only does batch processing, but also it can do streaming audio. And this is umpteen number of use cases, whether it's in some sort of video conferencing application or somebody chatting over the phone. So this is, again, very similar to what we do in the Vision API. Our structure is very similar. We want to use, well, if you use once, you should be able to use every other API. Again, you create a JSON query, send the response, either embed the file, audio file that you want to transcribe, and the language. By default, we take the English language, run the API, and back in Get, you get the response with the embedded text. Same thing with streaming audio. It's a two-way street, so as you are streaming audio, it on the fly transcribes what's in the audio, it sends it back, so you can display what's being said in real time. Very similar to Vision API. No more than 20 lines of code, you should be able to use this up and get go. And only thing in the case of audio files, you have to identify the encoding and the sample rate, and then you are good to go. So again, this is something, right now this product is in alpha. We are planning to go beta pretty soon, and we have got tremendous response from people who are using this and using it in multiple use cases. For example, as I said, enabling chat and messaging apps is a great example. Gaming. Surprisingly, we found game developers using this to control their gaming environment using voice. Home automation and another big use case for us. This is really about your embedded devices, which do not have a UI where you can type, but you can speak to the devices, and then you can control those devices that way. Meeting analytics coming from the Google Apps world. This is something we have seen tremendous response and appetite from our developer community to use. And the traditional, very old, for the longest time, text analytics in the enterprise has relied on call center analytics. And not only we can transcribe in real time what's going on, or the conversation you are having with your customers, but we can also understand, based on simple your own models, what's the sentiment on those speech to text converted streams. So let's do some demo. Again, I'll start with a simple, let's see if we can make it work. So this is like, today you can go right now. This is, important thing to understand is this technology has existed for the longest time at Google. So if you have used voice recognition on your Android phone, we are exactly exposing that same thing. And as you can imagine, to do good audio recognition on a mobile phone, which is typically very noisy, you have to have the science right. And this is really built on the deep learning based model that we have been using and refining over the last 4 to 5 years. And that's what we are exposing. And as recently Jeff Dean said, we are embarking on a new sort of spring of AI. And the best example of that is the amount of reduction in error rates we have seen in speech. Just 3 or 4 years, this kind of error rates and low error rates were unheard of. This space and this sort of field has been stagnant for years. And then applying neural nets, we were able to achieve, not only just Google, but a lot of other folks in the industry, and it's mostly in academia, we were able to achieve some unheard of audio quality. And I think we are getting to a point where pretty soon your interface to your phone or your app will be voice. So let me show you something here. So simple demo. Are you guys having fun? Okay, I need to talk to this. Are you guys having fun? I didn't hear that. Um, is this a cool demo or what? Never easy to do. Is this a cool demo? Is this a cool demo? Audio is always interesting to do. But more importantly, I think as you build your models, you will realize, okay, I should turn it on. As you build this model, you will have to have, and I think this is something we learn on our Google search, you have to have some sort of error, ability to handle error, and incorporate that in your app. So give you an example. This is pretty simple demo, to be very frank. When I'm speaking into this, it's sort of because of the echo. But imagine you're taking an app. Take an example of, hold on. So that demo that I showed was pretty straightforward, converting audio into real-time audio into text. But I think the beauty of it, how do you take that and improve your own apps and app experience? So Google, this is Gmail. Almost everybody's familiar with the Gmail interface. And if you want to search something in Gmail, you literally have to know the keywords to search for. So it's easy to search from, hey, show me emails from Salesforce, so which is pretty straightforward. And then you can do that, and it shows you all the emails from Salesforce. But imagine you have to run a little bit more complex query. Show me attachments from Google or like whatever. And I don't even know how to construct that query because Gmail search, even though search is core part of Google, is still very keyword focused. And to identify that I want emails with attachment and from a particular sender is no easy task to construct that. So how would you change and completely transform this experience if you're building an app like that? And so we used the speech API to build a very simple Chrome extension and to show you what could be done if you're building an app, something like this. So you go back here. So this is just to sort of give you a little background. So this is literally a simple Chrome extension that you can write within like no more than like 200 lines of code, where all it does is takes speech, calls the speech API, converts into text, then parses the text to construct the query that we are going to see. So let's take example. Show me email attachment from Google. So again, something like this, a query like this, guys, this worked. So, so again, doing any audio demo in a noisy environment is always tricky, but the demo god was with me, and this worked. But imagine this: because we have perfected this technology on mobile and audio, which is very inherently noisy, our benchmarks say we are better than anybody else in the market today. Again, go back to this example. A query like that is pretty difficult to construct by your users. And Gmail is one of the most widely used software in the world, email client in the world. And even there, people are not used to something like this. But if you're building an app, doing queries like this and fundamentally changing the interface that users interact with you is a great opportunity for you. So going back, so this is a summary of the speech API. Again, this is because we have essentially using what is in Android. It's from day one, it can understand 80 languages and more. It's one of the best, highest quality voice recognition system out there today. It's highly accurate, and it's more importantly, you can, because it does real time and batch both, you should be able to use it in a wide variety of applications. So more information is available on these websites. Again, vision, speech, and translate are all out there in the public, more to come. And that's the way to contact us if you have any questions. So that's all I have. I'll open up for any Q&A. Sure. So we talked about Thank you.
Quick question on the OCR. OCR works great on a printed word. If it's a handwritten note, how does OCR work? Because every handwritten style is different.
So yeah, the quality on handwritten is not as good as on a printed text. But again, it depends on the very specific example that you're trying. And I think I would encourage you to try out the API. For specific languages, we do a lot better. English, transcribe, even handwritten, we are way ahead. But in some other languages, we are not that good. So I think it depends on the language, it depends on the style, it depends on the angle, and so many factors. But I think the point I was making here is the quality has improved tremendously over the years.
On the facial one, you don't do age or race, demographics, that kind of stuff?
No, we don't. So we only show, recognize the face, and we recognize the emotion. We don't even do age yet. I think because we don't, again, we can do internally, we don't expose models that we fundamentally believe will give you mixed results.
Oh, okay. So it's not like, it may be coming in the future is what I'm hearing.
Hopefully in future, because it's a tricky machine learning problem. But I think for the way I would encourage you, for your use case, use the API and see if you can get really great results. And because in case of stock photos, it's really well, because stock photos are taken with right lighting and resolution, but random images taken in dark might not do so well.
I approve. Nice presentation, good demo.
Thank you.
Question on, for new parents, I've heard a use case where there's apps to, point your app at your baby's face and it tells you, what might be happening. I don't know if this use case is something you've heard at all.
Sorry, I didn't catch the news.
So imagine you have an infant, okay?
Yeah.
New parents have a lot of stress. My baby is crying. What is this? Is he choking? Is he just crying? Is he constipated? I don't want to go into details, right? But I heard about app which can recognize your baby's expressions and basically tell you this is what might be happening.
So again, I think that's a very noisy output. So again, our philosophy is we won't be able to do it using the Vision API, because to do this, this is where you'll use a cloud platform, machine learning platform. So what it is, if you train your models around a very specific baby face use case, and then label that and train that model to sort of identify, self-identify specific cases, I think you can build a model on top of it which is much better than the Vision API. But that is very directed towards, and then the beauty of this is we are providing you all the tools that you can build this model on your own. So yeah, so for vertical, like medical is another big, huge use case for us, where within like particular identifying disease based on like, hey, looking at the eye color, identifying what kind of potential diseases, diabetic or and so on and so forth is possible. But again, the Vision API as of the box is not addressed there.
Would you have to use it with something like a TensorFlow or a different package to do that?
So yeah, in this case, depending on the typical, the breadth of models and the how deep you want to go, TensorFlow is one of the models frameworks that I will use. So it need not be always the deep learning or neural nets need not be the best model, give you the best quality at the right time. So in some cases, linear regression probably works better. So you really have to play with, and this is where a lot of the rocket science of machine learning comes in. The tools are there, but what tools work at what time and what use cases is something that you need to do. And I think that's our philosophy, is to increase that and give you all the tools and also provide you a lot of insights. Hey, for this particular use case, probably use this model.
So I have a question about the speech recognition. Is it like customizable? Like, because people have different dialects, is it possible to, customize depending on, like, this person can train his maybe own model, like?
So you can build own models on top of it. So we recognize 80 languages. There are some dialects of Mandarin that we, frankly speaking, would not be able to identify. But assuming it's the closest, because it's built on neural nets, the neural nets, what they do is associate and give you the results with the closest cluster or results with that. So that's we can do. So, but the vision of speech API is you can take the input and build and customize your model on top of it using TensorFlow. So that's possible.
I see. Okay, but you have to.
I have a question regarding Vision API. So,
Sure.
Can it identify the difference between indoor picture and an outdoor picture? So, for example, I'm interested in finding out a picture that shows kitchen versus bedroom.
Yeah, that's a good point. So in fact, we are, without the names being told, there is a company which is we already looking at, which in the real estate market, which is looking at our models, and they will have to customize a little bit because we can't recognize, we cannot recognize this is a bedroom yet. It can recognize interior, exterior, I believe, but that's not part of the feature. Okay. So you have to take that output from the API and build a customized model around it. I guess the last question.
So you showed us, like, with the static image, you are able to identify a lot of things. But if it's a video, is there a way where you can?
So stay tuned for future announcements. Awesome, guys.
Are you using the geolocation metadata in pictures to identify the landmark?
Yeah, so it's based on not only landmark, but if the image, not every image has geolocation data. Yeah, so if it is common landmark, then we don't even need the geolocation. But if it is, so more information you give. So right now the API does not expect geolocation information embedded.
It would be a great help because it directly attaches the image to exactly what it is. Because if you know the location, you actually can use that as additional training because you already know what the image is.
Yep, that's right now, but it does not. So.